Hey everyone, so in this video we're going to be covering 10 of the most important and common question types that you need to know for the SAT math exam. Now, if you want 50 plus SAT math questions, we have a playlist I'll link down below. As always, try the problems on your own before watching the solution, and good luck on your exam. So it says a rectangle is inscribed in a circle such that the vertex of the rectangle lies on the circumference of the circle. All right, first let's just draw this out, right? So the first thing you have to do with these geometry problems is interpret them. And, there's all this weird wording there, but as long as you just take it step by step, word by word, you'll be fine. So the rectangle is inscribed inside of a circle. So let me just draw a circle and then draw a rectangle. So the rectangle is drawn such that the vertex, or each corner of the rectangle, lies on the circumference of the circle. So what it's going to look like is one corner goes there, boom, and then the corners of that rectangle are going to be on the circumference or the outside of that circle. So there's our drawing. It says the diagonal of the rectangle is twice the length of the shortest side of the rectangle. All right, let's draw that in. So the diagonal, which is going to look like this, just going across from one corner to the other, is going to be twice the length of the shortest side of the rectangle. So this right here is our shortest side, and so let's just label that x. Let's call that x. And it's twice the length, so we can call this 2x. Therefore, that is twice the length. The area of the rectangle is 1089 times square root 3 square units. What is the length in units of the diameter of the circle? All right, so the diameter of the circle, right, is just its radius times 2, because that's just from one end of the circumference to the other end of the circle. And you can see that the diagonal actually, satisfies that condition. And therefore, the diagonal of this rectangle is that diameter of the circle. But how do we actually find our side lengths? Well, you have to use this thing on the side. That's the reference table that the digital SAT provides, right? This is provided to you. You have to focus up top on the special right triangles, all right? So if you're not thinking of special right triangles, you might be in a bottomless pit trying to solve this problem, because special right triangles is the easiest and fastest way to do this. So you can see here, for one of our special right triangles, the 30, 60, 90, we have side lengths 2x, x, and x times square root 3. That matches up with this triangle over here, right? We have side lengths x for one of the legs, the hypotenuse is 2x, and therefore we can infer that the other side is going to be x times square root 3. So x times square root 3 is going to be our final side for that part of the rectangle. And we know length times width equals the area of a rectangle. And we have the width right here and the length right here. And so we just have to multiply those together. So x times x square root 3 is going to give us the area that they provided. So it's 1089 multiplied by square root 3 square units. And all we have to do now is solve for x. So you can plug this right into Desmos and I'll give you an answer of x equals 33. And so now that we know what x is, all we have to do is plug it in here, right? So x is 33, so we know one of the side lengths is 33, but that diameter is that diagonal of the rectangle. And the diagonal of the rectangle is 2x. And so 2 times 33 gives us 66 as our final answer. All right, so this SAT math problem says the positive number a is 2,241% of the sum of the positive numbers b and c. So a is going to be equivalent to 2,241% can be represented as just 22.41 times b plus c. And if this doesn't make sense, just think about it as if we were talking about 200%. 200% is the same as doubling, right? And in this case, then we would say something like 2 times b plus c, right? We're just doubling the value 200%. Now that's different than a 2,241% increase. Then you would have to tap into percent multipliers and that kind of stuff. But anyways, this is what we have so far for the first part of the problem. It says B is 83% of C, and the question says, what percent of B is A? So right now, because we know this, B is 83% of C, we can actually replace B in our current equation with the variable of C. So you have A equals 22.41 as our factor. B is 83% of C, so we can write 0.83 C plus C. So this part right here is just B, but represented in a different way. And so knowing these values, how can we determine what percent of B is A? So in this case, what we can do is just pick a random number for C, right? Because we have a missing variable C, but we need to determine what A is. So if we determine what C is, then we can find the value of A. So how we're going to do that is just plug in 1, right? Let's just use 1 for C. So in this case, then this part right here would then be equivalent to 1.83. And then we're going to multiply this by 22.41. And that will give us a value of about 41.0103. So we have our A value, but what we need to do is compare it to the value of B. Well, the value of B here we said was 0.83C, and we said C was going to be 1. And so in reality, our B value, quote unquote, is going to be 0.83 in this case. And so what we can do is just set 41, our A value, 0.3, over 0.83. And this is going to give us a value of 49.41. Now here's a trick question, right? This is 49.41x, right? This is the factor. So our A value is 49.41 times larger than 0.83. That's different than the percentage, right? If we look up here, 2,241% translated to a factor of 22.41. Therefore, a factor of 49.41 can be attributed to the same scale of 2,241%. This will be the same as 4,441%, and therefore our correct answer is going to be D.
This one says, in the figure shown, lines R and S are parallel and line M intersects both lines. So we got a parallel line cut by a transversal, so we want to be thinking about vertical angles, alternate interior angles, all that stuff. If Y is less than the value of 65, which of the following must be true? So let's just go right through it. So it says X has to be less than 115. So X is this angle right here. And because it says Y has to be less than 65, and which of the following must be true for all values of Y, we could just plug in a random value for Y. So let's just call Y 64 degrees, right? Because that satisfies that equation. And so now we know that this Y right here is 64 degrees. And so the angle opposite of that, that's going to be vertical angle. So this is also going to be 64 degrees. And we can see here that this 64 degree angle and angle X, these are consecutive interior angles. And so what happens is that they are supplementary. So they have to add up to 180 degrees. So you get 180 minus 64, which gives us, oops, that was real messy. Okay, 64 equals 116 degrees. So interesting note here is that 116 is greater than 115. So that does not add up with A, and therefore A is wrong. If we were to lower this angle, which we would have to, I mean, if we had like 64.99, we would end up getting what, like 115.0001, right? But let's see if B is true. So it says B says X has to be greater than 115. Is that true? Well, we know that the biggest value of Y that we can have is 65, or not even 65, because it can't even be equivalent to it. It would have to be like 64.999. And therefore, if we had 180 minus 64.999, etc., right? That would yield what is that? 115.0000, etc., 1, right? That's messy, but you get the point. So basically, we can't ever go underneath 115 degrees for X if Y is less than 65. Therefore, B is our answer, but let's just check the other answers to be sure. So it says X plus Y has to be less than 180 degrees and X plus Y has to be greater than 180 degrees. Well, we just proved it here, right? We said that if Y, we could just name it 64 degrees. Vertical angles, this is 64 degrees. We find that X would have to be 116 degrees. 116 plus 64 is 180 degrees, and so neither C or D is correct because x plus y will always be equivalent to 180 degrees, which expression is equivalent to 42a over k plus 42ak, where k is a value greater than 0, and we get all these answer choices. Alright, so what we're going to do here is pretty much just try and simplify this into its simplest form, essentially. So we get 42a, oh wait, actually, let me backtrack. So you get 42a over k, right? And we get 42ak over 1, let's say. And now what we can do is actually find the common denominator here. And the common denominator is very simple for this problem. It's just k, right? So this right here just stays as 42a over k because it already had k in it. And we want to add, and we're going to multiply this 1 by k, right? So we're multiplying both the numerator and denominator by k. So we get 42ak times k. And the reason we're doing that is to find a common denominator, and the k's here, k over k is 1, so it really is the same thing, right? It's the equivalent expression or form, but we just want a common denominator here because now that we have the same denominator, we can combine the numerators. We get 42a plus whatever over k. And so now we can see that k is going to be applied to this value. Now, be careful here, it's not distributive property. This 42ak, look at it as one term, right? One singular term. So this k can't be applied to the 42, can't be applied to the a, but can be applied to the k value. So now we get 42a k, and the k times the k is just k squared. All right, so now we need to factor out the greatest common value from the top. So that is going to be 42a, and 42a times 1 will give us this first value of 42a, and then plus k squared, which is going to give us 42a times k squared will give us the second value all over k. All right. So after doing that factoring, you realize that the answer choice that we got matches up distinctly with answer choice D. It's just flopped, right? This and this is flopped, but it is what it is because it's the equivalent form. Therefore, D is our answer. Now, you could have done it a different way and gotten the same answer, or you could have even used Desmos, right? Just plug all the equations in, set a value for A and K, and you're good to go. But this, I thought it was, pretty straightforward and efficient. The salesperson's total earnings consists of a base salary X dollars per year plus a commissions earning of 11% of the total sales the salesperson makes during the year. All right, so let's just write this out. So the salesperson is going to make a base salary of X, and he's going to get on top of that 11%. So we'll just express this as 0.11 of the total sales. So the total sales, let's just call it S. Okay. So it says this year the salesperson has a goal for the total earnings, so this value right here, the total earnings, to be at least 3 times and at most 4 times the base salary. The base salary, remember, is the value X. Which of the following inequalities represents all possible values of total sales S in dollars the salesperson can make this year in order to meet that goal? And so we just have to write our inequality out. So I'm actually just going to erase this and write our inequality. So we know that has to be at least 3 times the base salary. So 3x is less than or equal to our total earnings, and at most 4 times the base salary. So that's going to be less than or equal to 4x. All right, so now that we're looking at our answer choices, none of them actually line up, right? C is similar, right, with 3x and 4x, but it just has s in the middle, whereas we have x plus 0.11s. Therefore, in order to actually get an answer that matches up with one of the answer choices, we need to simplify this inequality. So here, very simple, we can just subtract x on all sides, and we end up getting 2x less than or equal to 0.11s is less than or equal to 3x. And now again, we want to isolate for S because you see in all these answer choices, S is by itself in the middle as the total sales. Therefore, we can just divide all sides by 0.11. So we get 2x over 0.11 is less than or equal to S less than or equal to 3x over 0.11. And we can see that this answer choice right here lines up directly with answer choice B, and therefore that is our answer. All right, this one says the manager of the online news service received the report above on the number of subscriptions sold by the service. The manager estimated that the percent increase, from 2012 to 2013 would be double the percent increase from 2013 to 2014. How many subscriptions did the manager expect would be sold in 2014? So there's going to be a percent increase from 2013, so it's going to be a value above 5,880, which is represented by the answer choices. So now we just have to find our percent increase from 2012 to 2013. Okay, so to do that, we're just going to do 5,880 minus 5,600. So if you took to chem, it's kind of like final versus initial over initial. So our initial here would be 5,600. 5,600. Or I guess if you're talking about math, it would be new minus old over old. But what we have here is 280 over 5,600 is going to be 0.5. So that is the equivalent of a 5% increase. Okay. Now in the problem, it says that the manager expects that the percent increase from 2012 to 2013 would be double the percent increase from 2013 to 2014. So this number right here is double the percent increase of 2013 to 2014. So we just take half of that, that's 0.02, or a 2.5% increase. So now we just need to apply a 2.5% increase to our 2013 value of 5,880. So I'm going to go up here, let's write 5,880 multiplied by 1.0. Let me just make sure I get the decimals right. So that's a 2.5% increase, so that's going to be 1.025, yes. So this right here, just so you never get it wrong, there's a formula. You get 1 plus R over 100, and then R is like your percent. So in our case, it'd be 2.5. So 1 plus 2.5 over 100 is indeed 1.025. So that's just a nice trick to never get those percent increase and percent whatever's questions right. So 5,880 times 1.025 is going to give us a value of 6,027. So that lines up with answer choice B as our final answer. The factors of 2x cubed plus 42x squared plus 208x is x plus b, where b is a positive constant. What is the smallest possible value of b? So this one takes about 10 seconds to do with Desmos. You can see right here, all you gotta do is plug it in and look at the intersections here. So we can see that it has to be a positive constant, and so that intersection at 0 doesn't count. And we have negative 80, right? Negative 80 is a solution, and therefore when it is written in factored form as x plus b, that is the same thing as x plus 8, right? Because if you're set to equal to 0, subtract 8 on both sides, and you would get 8 equals negative 8. The long way to solve this is just to factor it out, right? Factor out 2x, and then you would factor out x squared plus 21x plus 104, which gives you x plus 8, x plus 13. So it's pretty much the same thing, but we know here using Desmos that the smallest possible value, b, is 8. The quadratic function models the height and feet of an object above the ground in terms of time and seconds after the object is launched off an elevated surface. The model indicates the object has an initial height 10 feet off the ground and reaches its maximum height 1,034 feet above the ground 8 seconds after being launched. Based on the model, what is the height in feet of the object above the ground 10 seconds after being launched? So a really easy way to solve this problem is just to use Desmos, right? I know it's crazy. Desmos is so easy to use. The only problem here is you have to do a little extra thinking, right? It's because they don't give you all the coordinate points that you need. We do know a couple things. So we know that the initial height is 10 feet above the ground. So when x is 0, we're going to have a value of 10. So that's our first coordinate point. And they also give us the maximum value of 8 seconds after being launched. It is 1,034 feet. Now, the only problem with regression is that to use regression on Desmos, you need to have one extra coordinate point above your degree of the polynomial. So if I had a linear function, I could have 2 coordinate points and it would work. But since I have a quadratic, I need 3 coordinate points to make it work. Therefore, to find the last coordinate point, it's actually not that hard because you have to think about a quadratic function, right? If I have a quadratic function, I'm going to draw the other axis, and then the graph is going to look something like this, right? And what we know about quadratic function is that it's symmetrical, right? So if you were to think about this as 0, 10, right? And we think about the axis of symmetry as x equals 8, we know that everything is symmetric, right? So if this is x equals 0, and then this is x equals 8, then this value over here, when it returns back to the starting value, that has to be x equals 16, right? Because this is a change of 8, and this is also a change of 8. Side of the axis of symmetry is equal. Therefore, to find our other coordinate point, it's actually pretty simple because we know that this value, when it returns, has to have a y value of 10. And we already said that x is going to be 16. So we have 16, 10. We have our 3 coordinate points now, and now we just plug this into Desmos. As you can see here, just a table with the points, and we put in our regression, and it gives us our graph, right? It gives us the A, B, and C value. But the question is asking, what is the height and feet of the object above the ground 10 seconds after being launched? So since we already have the function that represents the problem, all we have to find is the value of the, what is this? The object, okay, the value of the object, or the height of the object 10 seconds after being launched when x equals 10, right? So we just put in x equals 10 here, found the intersection, we see that when x equals 10, the y value equals 970, therefore our answer is choice C. Alright, so this problem says if 4a over b equals 6.7 and a over bn equals 26.8, what is the value of n? So to help us find the value of n, it'd be very helpful for us to scale up everything, right? Because we already know what 4a over b is, that's equivalent to 6.7, so we can use that to help us compare the values to ultimately find n. So if we were to scale up this entire equation by 4, we'd have 4a over bn, and then we would have to multiply 26.8 by 4, which gives us a value of 107.2. Alright, so now it's just time to simplify, right? So what value of n would make this true? Well, because we don't actually know what the value of a or b is, we have to infer that based on our given information. We know 4a over b is 6.7, and we have 4a over b in our equation. So this simplifies out to just 6.7 over, and we have our n. So 6.7 over n is equivalent to 107.2. You can rearrange this to solve for n, and we would get a value of 6.7 over 107.2 equals n. And 6.7 over 107.2 also just simplifies to 1/16, and therefore our value of n is 1/16. Sample of a certain alloy has a total mass of 50 grams and is 50% silicon by mass. Okay. The sample was created by combining 2 pieces of different alloys. The first piece was 30% silicon by mass, and the second piece was 80% silicon by mass. What is the mass in grams of the silicon in the second piece? So to solve this problem, we need to set up a system, right? So what we know now is that the first piece and the second piece make up this certain sample of alloy. And so what we can determine is that the total mass, this is pretty much the only information we're given in terms of actual mass, is that the total mass of the alloy is 50 grams. So we can write 50 equals, and now we need to create some variables. Let's create it as x and y. So what we want to define here is essentially x is just the mass, total mass, important to note, total mass of the first piece, and then y is the total mass of the second piece. But what we want to solve in the problem is the mass in grams of the silicon, only the silicon in the second piece. So how exactly do we do it? Well, we have to read in between the lines. It says that 50% of that 50 grams is silicon. So 50 divided by 2 is 25 grams. So we only have 25 grams of silicon in that sample. Therefore, we can set 25 equal to, well, what are our other given equations? Well, not equations, but variables. We have the first piece, which is 30% silicon by mass, right? So you know X is the total mass, and therefore now we only have 30% of that for silicon. So we got 0.3x, and now we've got to do the same thing for the second piece, which is 80%. So 0.8 times the total mass. All right, so now that we've got these two systems of equations, we go over to Desmos and plug it in. So we can see, guys, we plugged it in here and we find the intersection. So this is our corresponding X and Y values. It says what was the mass in grams of the silicon in the second piece. Remember, we labeled Y as the second piece, the total mass of the second piece. And so the total mass of the second piece here is, you can see, 20. So 20 grams is the total mass. This is the total mass, not the silicon of the mass of the silicon, right? To find the mass of the silicon in the second piece, we need to multiply it by that 80% factor, right? Because only 80% of that 20 grams is actually silicon. So 20 multiplied by 0.8 gives us a grand total of 16 grams of silicon. Therefore, B is our answer.